All right, this is lesson 3 of topic 3, day 2. This is the last lesson of this topic. So we've got a little bit of mix of everything, the laws of exponents. We got some pretty difficult questions here for the warm-up. So we've got a coefficient of 2 being multiplied by x to the negative second power. We want to make that x to the negative second power. We want to make it a positive power. So we're going to flip the x, that base alone, not the 2. The 2 is going to stay right where it's at. But the x to the negative second is going to flip to the bottom and become x to the positive second. So there's your answer. Question number 2. Leave the coefficient right where it is. M to the negative third becomes m to the positive third after I place it on the bottom. And n to the fourth stays on top because it was already a positive exponent, so leave it right where it's at. So basically you're mixing and matching and moving pieces like a puzzle, and you're moving them based on whether or not you have to move them or not. So just look at each base and keep it separate and move it and not. So 3 stays on top. X to the negative second means the x goes on the bottom, becomes x to the positive second, because you don't want any negative exponents in your answer. And y to the negative fifth becomes y to the fifth on the bottom. Done. Question number 4. All right, so the first thing I need to do is raise powers to a power rule. I got to use the power to the power rule to figure out what it will be. So that's going to become x to the 6, because you multiply a negative 2 times negative 3. Y to the 2 times negative 3 makes negative 6. Then I'm going to simplify that. X to the 6 stays on top, and y to the 6 now goes on bottom. Because negative exponent, flip it to the bottom. All right, next one. We got a coefficient raised to the negative second power. So 4 becomes 4 to the negative second, which becomes actually 1/16. Or you could say 1 over 4 squared. Okay, which is 1/16. And x to the fourth power. Okay, so you know what? I better go back. Oh, that's not what I want to do. So let's do this a different way. Let's do 4 to the negative second power. X to the 4 to the negative second becomes x to the negative 8th. Y to the negative third to the negative second becomes y to the 6th. Okay, so now let's do it in 2 steps. So now 4 to the negative second goes on bottom, becomes 4 to the second on bottom. X to the negative 8th becomes x to the 8th on bottom. And then y to the 6th stays on top. So the answer, I'm going to take it one step further. This is probably the best way to explain it. Y to the 6th stays on top. 4 to the second power becomes 16 on bottom. And x to the 8th stays x to the 8th on bottom. So there's your answer. Okay, and I broke it down step by step. I think that was the best way of doing it. So first thing I did was I did power to the power rule, and then I did negative exponent rule by moving negative things to the bottom, and then I just cleaned it up a little bit by making the 4 squared 16. All right, so done and done. All right, so this is the one I know I talked about in the last video about the computer virus. Well, this is it. This is the computer virus question. It happens to be question number 2. This is about word problems, and this video might be a little bit long, so I'm going to go through these one at a time. Sally leaves a serving of yogurt, and this is kind of like the question we did in the last lesson. The number of bacteria in the yogurt is a factor of 4. 25 minutes later, so that's 4 to the x power, is equal to 25 minutes later, Lupe leaves a serving of yogurt. But due to the increase, it goes to a factor of 8, and it's to the x minus 25th power. Yeah, that's the bell. Looks like it's third period now. All right, so I'm going to change these so that it makes the bases the same. So this becomes 2 squared to the x power equals 8 becomes 2 to the third power to the x minus 25. Okay, so this becomes 2 to the 2x. And this becomes 2 to the 3x minus 75. All right, so now the bases are the same, so I can cancel them off. I'm going to continue over here. So we got 2x equals 3x minus 75. Subtract 3x from both sides, subtraction property of equality. And that's going to leave us with negative x equals negative 75. Multiply both sides by negative 1. X is positive 75. Yeah, look at all those steps. That's a lot of steps to get to that answer of 75. It's not the only way. If you try to make a list and go all the way down to the 75th minute, that is going to take you forever. So I know you're thinking this is a lot of work, but this is a lot less work than making a table going down 75 minutes. That would take way too long. Question number 2. All right, so this is a computer virus one. So one of the computer viruses multiplied by a power of 3, that's 3 to the x, is equal to, at 12 minutes at noon, afternoon, a much worse computer virus affects another computer's memory. Each minute thereafter, a computer infects, 9 times. So 9 times, but it started 12 minutes later. So it started 12 minutes after. All right, so 3 to the x, keep that 3 to the x. This is going to be a little bit easier. 9 becomes 3 to the second power. X minus 12 is on the outside. Cross off the bases. X equals 2 times x is 2x. 2 times negative 12 is negative 24. Subtract 2x from both sides gives you negative x equals negative 24. And then multiply both sides by negative 1 and you get 24. So it takes 24 weeks, I think, or minutes for them to be exactly the same amount affected in each computer. All right, so question number 3, geologist. So this one gets you thinking about time. Oh, no, time is the last question. So the first rock decreases by a factor of half. It's called half-life in science. That's a science thing. And this is going to be to the power of x is equal to a bigger rock, which is, it looks like it's decaying by a bigger factor of 1/4 each year. And that is going to be the t power. Sorry, it should have been t power, not x. That's what I get for not reading the directions. And I think it's starting later, if I'm not mistaken. Each year, again, due to the erosion, does that. Year since 2000. After how many years will both rocks be the same? At the beginning of the year 2000, discovered to be 1 megaton. Each year, due to the erosion. At the beginning of, what am I missing here? Beginning of 2010. My picture. That's what was causing me to not know. At the year 2010, that is 10 years later. There we go. I knew there was something that was missing. It's because my picture was covering it up. All right, so we need to make 1/4 the same as 1/2. So 1/4 is really 1/2 squared. Okay, and I really should not have written it like that, but that'll do, actually. That'll do. To the t minus 10 power. This is 1/2 also to the t power. All right, so now we cross off those halves, and now we've got t equals 2 times t is 2t, and 2 times negative 10 is negative 20. Subtract 2t from both sides, you get negative t equals negative 20. Multiply both sides by negative 1, you get t equals 20. It takes 20 years for them to be exactly the same. All right, hope you're in class. Maybe they're going to do a hall sweep. That was the beginning of the 3rd period. So, 4th one, a town in El Dorado was founded in 1680 with a population of 100. Every decade, ooh, that's gotta keep that in mind. The population of El Dorado doubled. The town of La Cruces was founded 80 years later in 1760 with a population of 100. Every decade, the population of La Cruces multiplied by 4. Okay. In what year were the population of 2 cities exactly the same? Founded and had a population of 100. And we're multiplying that every year doubled. Okay, so it doubled every 10 years. So it started in 1680. So if we're going to let x represent the year 1680, that's what we're going to do. Let x equal years since 1680. Well, how many years has it been since 1680? 0. So we're just going to put x right there. That's El Dorado. Equals La Cruces. Started off with 100 people. That's the starting point. Times it's being quadrupled. And it happened to be 80 years later. Well, how many decades is that? That is 8 decades. So it's starting 8 decades later. So you got to subtract 8 to represent those 8 decades later that it's starting. All right, so now we've got it all set up. We're ready to go. 4 is not the same as 2, so we got to make that 4 the same. So let's make it 2 squared to the x minus 8. Bring everything down. Ooh, this question is a toughie. Equals 100 times 2. Okay, so now this is the same, this is the same, this is the same, this is the same. Everything's the same except for the exponent. So I could have divided both sides by 100, but what's the point? Because they both start off with a population of 100. And that's going to leave us with x equals 2 times x is 2x. 2 times negative 8 is negative 16. Keep in mind, I'm multiplying by this 2. 2 times x, 2 times negative 8. All right, subtract x from both sides. 2x from both sides leaves you negative x. Subtract 2x equals negative 16. Multiply both sides by negative 1. X equals 16. There it is. All right. Finally, we're on to the homework. Sorry, this video is getting a little bit long. Solve each of the following equations. 2 to the 5th power equals 2 to the 2x minus 1. They both got base 2, so I can literally cross those off. Move me again. I'm in the way again. So that leaves us with 5 equals 2x minus 1. Add 1 to both sides. Divide both sides by 3. And x must be 3. All right, this one, bases are the same already. So get rid of the bases. Equals 3x minus 11. So I'm going to subtract x from both sides. And that leaves me with this. Add 11 to both sides. That leaves me with this. Divide both sides by 2. And that leaves me with, that is the answer. All right. So just listen to me talk myself through it. Because if you're just looking at this work, you're probably wondering what I did. 9 and 27 can both be changed to base 3. 9 is the same thing as 3 to the 2nd power. And then leave the 3x on the outside. That's the 2nd power. Equals 27 is 3 to the 3rd power. Leave the x minus 2 on the outside. Cross these off. 2 times 3x makes 6x. 3 times x is 3x. 3 times negative 2 is negative 6. Subtract 3x from both sides. Divide both sides by 3, and you got an answer of negative 2. Question number 9. Change them both to base 3. 9 is 3 squared to the 2x minus 1 power equals 3 to the 6x power. All right, so we've got both base 3s. So cross off the base 3. Keep in mind, don't want to get rid of the 2. We're just crossing off the base of 3. 2 times 2x is 4x, and 2 times negative 1 is negative 2. Equals 6x. Subtract 4x from both sides. Gives you negative 2 equals 2x. Divide both sides by 2 and you get negative 1. Great. Number 10. Change both to base 2. 2 to the 2nd power is 4. Leave the x minus 1 there. 8 is the same as 2 to the 3rd power. Leave the x there. Cross off your bases that are the same. 2 times 2x is 2. I'm sorry, 2 times x is 2x. 2 times negative 1 is negative 2. Yeah, this might be my longest video yet. I'm already at 12 minutes. 3 times x is 3x. Subtract 2x from both sides. That leaves you with negative 2 equals x. Done. Last question. Ooh, we've got base 5 and base 3. Ladies and gentlemen, there is nothing you can do to solve this question. You can't solve this because there's no way to make base 5 into base 3 or vice versa. I don't want to completely lie to you. There is a way to solve this. It's just you don't know how to do that yet. It takes a logarithmic function in order to solve this equation. So for the time being, we're just going to have to put a, can't solve yet, until you learn how to do logarithmic functions in Algebra 2, which is 11th grade math. All right. Hope you enjoyed the video. I know it was long. Let me know if you have any questions. Thank you.